Woo! We just did double angle formulas. Now we are going to do some half angle formulas. I did 2 test videos before this to see if I'd get any feedback. I didn't get anything, any of that stuff. Hopefully it's not happening right now. So I'm just going to go for it and record this entire video. Fingers crossed, did 2 tests. We're good. All right. So half angles, we are going to derive one of the formulas, okay? So if we let alpha equal x over 2 for the cosine formula and solve backwards for sine of x over 2, then we'd get this whole wonderful thing. I'm going to leave it typed up. We already had it typed up in our notes. But let's go through it line by line. So I know that cosine of 2 alpha is equal to 1 minus 2 sine squared alpha, right? That is one of my 3 versions of that formula. So if I substitute in x over 2 for my alpha, I've got this. Now I have 2 times x over 2, so that's where I get just the x from, right? And then that's it for that stuff. Okay, I don't know what I was going to say there. Continuing on. So I'm going to subtract 1 and then divide by negative 2, which brings me all the way down to this spot here, right? I subtracted 1 and I divided by negative 2. Pause if you need. And that equals sine squared x over 2. Let's do a little rearranging. We now have 1 minus cosine of x over positive 2. So we divided through that negative and rearranged a little bit. And that's equal to sine squared x over 2. And if I square root on both sides, I end up with this formula where I have the positive and negative versions of the square root of 1 minus cosine of x over 2. So plus or minus square root of 1 minus x over 2. Cool. All right, so we derive that from our double angle formula. Much like we've been doing with all these, they can all just be derived from one from the next. It's pretty cool how that all works. So we could do this for the same process for the other ones as well, but we will just go through and give these to you. So if you'd like to take a pause real quick and jot down these formulas, I'm going to screenshot them and bring them into each problem just as we're working with them. These are not ones that we're going to expect you to memorize here. All right. So here's what we got. Sometimes you're given angles that, again, are not like our 45 degree or our 30 degree or our 60 degree, right? Perhaps you're given an angle like 22.5, right? Well, 45 over 2 is equal to 22.5. So if I had, let's say, sine of 22.5, well, I could rewrite that as sine of 45 over 2. And now this 45, well, that's my x that's going into that formula, and I can evaluate cosine of 45, right? So I can now work with my nice trig values, or my trig numbers there, and work through the problem, okay? So it's going to be kind of messy, but it gives us a way to work with these things and get exact answers from, not so nice angle measures. All right. So I've got this first one here. Simplify the expression in terms of A. Well, this certainly looks like this guy right here. So this is a tangent half angle formula, right? So my x, that is my 6a, right? My x is my 6a. So this is going to equal tangent of, well, x is 6a over 2, which is just tangent of 3a. That is it on this one. I know sometimes it's like, wait, what? That's all I had to do? Yep, that's all we had to do on that one. Cool. Let's go to example 2 now. Oh boy, we got real stuff going on. That was the end of the period. Evaluate using a half angle formula. Okay, so I've left the formulas up there. We're dealing with cosine, right? We're dealing with this one right here. So let me jot that down. Alrighty, I had to mask up here because I literally paused the video right after the last bell. Whatever. Mr. Philpott has joined us here. He's got himself some delicious looking food here. What is it again?
Queso birria tacos.
There you go. They look delicious. But I'm going to focus on my math. With tacos in front of me. This is incredibly difficult. All right. So we've got our cosine half angle formula. Now, I want you to take a look at what's highlighted in yellow there. It says determine if it is positive or negative from the angle given. Not whether or not that angle is positive, but what quadrant it lies in. 3 pi over 8 lies in the first quadrant, so it is going to be positive, okay? Cool, wonderful. Some people like to deal with this in degrees rather than in radians. Totally up to you how you'd like to go about doing that. But let's go ahead and go into degrees on this first try here just to make some sense of it. So if I were to convert 3 pi over 8 into degrees, that'd be 67.5. Again, we can clearly see it's in the first quadrant. So let's see in our formula here, we'd have cosine of, then that would be 135 over 2 because that equals 67.5. And now I can plug the 135 in for my x into the formula. Now, let's say we saw that in radians, you would really be looking at it like this. You'd have 3 pi over 4. I don't like how the slashy fraction's looking. 3 pi over 4 over 2. It looks pretty nasty there, but you can still see that this is what I'm plugging in for my x into the formula. All right, let's go for it. All right, so in any event here, we have our cosine of 135 or our cosine of 3 pi over 4, depending on which route you went. Again, you can choose whatever you want to do. You can convert to degrees if you'd like, if it's easier for you. But I just wanted to show both ways here on this first one. All right, so now we'll evaluate like normal. So I'll just go with one of them since they'll all be the same. By the way, we said it was going to be positive, right? Why am I writing this plus or minus anymore? We're just going to go straight positive there. Bless you, Mr. Philpott. And then let's see here. Cosine of 135. That is going to be negative root 2 over 2. All over 2. Oh, this is just wonderful. All righty. So now, let's see here. We got the square root of. Mr. Philpott's using the loudest napkin in all of Illinois. Actually, this side of the Mississippi, I believe that was the loudest napkin. All right, I can multiply. If I want to get rid of that fraction in the numerator, what if I were to do something like this? I don't know why I'm going to a totally different color here. We got, if I multiplied numerator and denominator by 2, meaning multiply by 2 over 2, or a clever form of 1, as I like to say, I would get 2 plus, and then these would end up canceling each other out. That's why I did that. So I'd have actually minus root 2 all over 4. And now I would have 2 minus, hold on, 2 minus root 2 in the numerator all over 2 in my denominator. Oh, that is beautiful. A square root instead of a square root. Ooh. Radical and a radical. This is a double radical problem. I know how much you love it. Fantastic, wonderful. We're going to continue on here. I'm getting so hungry smelling the delicious tacos in this place. But I'm going to try to focus on the math. So we're going to evaluate using the half angle formula once again here. We have sine of negative 105. So first things first, what quadrant does that fall in? This would be in quadrant 3 for negative 105. What do we know about sine in quadrant 3? It is negative. So we'll be having negative square root of in our wonderful, fantastic formula. All right. Now, let's rewrite negative 105 as something over 2. That would be sine of negative 210 over 2. Wonderful. Fantastic. Mr. Philpott is really trying to be quiet over there. I can tell he was bringing his napkin below the table to wipe his hands to maybe block some sound. He's really trying his best. But as usual, it's usually never good enough for Mr. Philpott. Oh, that's a burn. I love you. Sorry. Okay. One.
You've been more of an interruption to your videos than I have.
That's true. All right. 1 minus, and then we got cosine of negative 210 over 2. Ooh, good stuff, right? So our x value, the part that goes inside our trig function in that wonderful formula, is that negative 210. And we've already taken care of the negative out in front based on the original angle in that trig function. Now let's evaluate. Instead of negative, then 1 minus. So what is cosine of negative 210? That is a 30-degree reference angle. So that would be a root 3 over 2. And that is in our second quadrant as we go backwards. So it'd be negative root 3 over 2. And all that over 2. So let's be careful here with all of what we got going on here. I'm going to scooch on over here where we got room. So I have 1 plus root 3 over 2 all over 2. And again, I'm going to multiply by that clever form of 1 of 2 over 2 so I can get rid of that guy right there. I don't want fractions in fractions, right? So this gives me 2 plus root 3 all over 4. And I can square root 4 nicely to give me 2 plus the square root of 3 all over 2. I accidentally dropped a negative somewhere along the way. There we go. Beautiful. Wonderful. Fantastic stuff. All righty. Again, that negative comes from negative 105 being in the third quadrant, which would make it negative, and then I can go about the rest of the problem, what's inside that radical there. Cool, wonderful, fantastic. There are a couple ways of doing these. You could get common denominators, multiply by the reciprocal when you're dealing with this, but I feel like that's just a little bit more complex. I think multiplying by that clever form of 1 is the way to go. All righty. Woo! Now we're not even dealing with wonderful trig angles. What the heck are we going to do here? All righty, Mr. Philpott is gone, done eating his lunch, and other people that came in here to warm up there. So we're ready. Okay. If cosine of b is equal to 2 over 3, find the exact value of cosine of b over 2, where b is an acute angle. So first off, I'm going to draw a triangle, much like we've done with these problems in the past. So I'd have 2, 3, right? There we go. Awesome. Wonderful. Cool. One thing that I just kind of brushed over is, wait, why did I draw it in the first quadrant, right? Well, it says B is acute, meaning B is between 0 and 90 degrees. So that lands it in quadrant 1. Okay, that's how we came to that conclusion there. Lovely, fantastic, wonderful. Now, we want to find the exact value of cosine of B over 2. So let's jot down our half angle formula. So we have square root of 1 plus cosine of b over 2. Now, we said it was in quadrant 1. The original angle's in quadrant 1. So that means we're working with the positive version of this, right? Awesome. Fantastic. So if I want cosine of b over 2, well, when I do this in the formula here, 1 plus, well, what's the cosine of b? Well, the cosine of b is 2 over 3. All over 2. Lovely. I feel like I said 3 over 2 or 3 over 2 at some point. I didn't mean to if I did. Okay. There we go. So I've got cosine of b is 2/3. Now what do we do? Well, how about we do that thing where we multiply by a clever form of 1. So if I multiply by 3 over 3, inside there, right, I'm going to end up with 3 plus 2 all over 6. So that means I have the square root of 5 over 6. Now, I cannot leave it like that. I have to rationalize because someone, someday said, hey, man, no radicals in the denominator. I ain't into that. And the math world took it as fact, and we just went with it. There we go. Square root of 30 all over 6. It is positive because it's in quadrant 1 because it said angle B is acute, which is between 0 and 90. That's how we came to that conclusion. I love it. Fantastic. We got 2 more examples here. Let's keep rolling. Let's keep moving. So sine of b is 4/5. Find the exact value of tangent of b over 2, where cosine of b is greater than 0. Okay, so cosine of b is positive. So if both sine is positive, right? Sine is 4/5. So that means I could have that in either the first or the second quadrant, right? This is either 1 or 2. Cosine of b, cosine is positive in either 1 or 4. So where is it located then? It's located in quadrant 1 for this one. So I can draw my triangle where I've got 4 and I've got 5, and that would be 3 for the last side there. Find the exact value of tangent of b over 2. Okay, so I've got my triangle. Now let's jot down our tangent half angle formula. All right. So I chose to use this one, the 1 minus cosine of b over sine of b. You could have done sine of b over 1 plus cosine But that just seems kind of annoying to have the subtraction happening in your denominator. I don't know. So I'm going to keep it like this. Now, let's go ahead and evaluate. So we're going to have 1 minus, and then cosine is 3 over 5, and sine is going to be 4 over 5. So if I were to multiply by my reciprocal, actually, you know what? Let's multiply by 5 over 5. Right? Clever form of 1. That would give me 5 minus 3 all over 4. Ooh, I like that. Giving me 2 over 4, and I get 1 half. Woo! That actually worked out very nicely, didn't it? So, again, multiplying by that clever form of 1 has been quite helpful in these problems here. You could have multiplied by the reciprocal of 4/5, right? And then, dealt with it that way. Either way is fine. I'm kind of favoring this lately. I know I've done the reciprocal before, but whatevs. All righty. Simplify sine of x over 2 times cosine of x over 2. So we're dealing with two half-angle formulas here. So perhaps I write out my half-angle formula. So we'll start with square root 1 minus cosine of x over 2 square root 1 plus cosine of x over 2. Okay, cool. Love it. Now, when we multiply these together, I can put everything all into one square root, right? Okay, let's do that. I'd have 1 minus cosine of x, 1 plus cosine of x, all over 4. Ooh. 4 is a perfect square, right? So, and I can also FOIL all this together. Let's do that. So I'd have negative cosine of x and positive cosine of x. That would cancel, right? And I would just be left with then 1 minus cosine squared x over 2. The numerator is in the square root. Not uh-oh. I don't know why I said uh-oh. Oh yeah, would be a better one. 1 minus cosine squared x is sine squared x, still in the square root, but I think you know what's about to happen. Sine of x over 2, or you could write it as, if you so choose, 1/2 sine of x. Woo! Either way is cool with me. Both of these are acceptable answers, whatever you did to come up with it. There is another way of going about this one. Totally up to you. I'm going to pause the video. I'm going to write that workout. So if you did want to try it that way, or you did it, you pause the video and you tried this one, you can see how it was done. So this is actually a little bit interesting. We ended up using the sine double angle formula, right? I took out a 1/2, factored out a 1/2. So I had to put a 2 here because remember our original was this. So I took out a 1/2 to make it look like it was the double angle formula, which could then be written as sine of 2 times the angle, which gets it down to then sine of x with the 1/2 out in front. Pretty interesting way to go about it. Very different ways. And you could have done it either way, which gets you the same answer there, the 1/2 sine of x or sine of x over 2. Your call. That's it for this lesson. I really hope there was no crackling in this one. We'll see. You guys have a wonderful day. America, freedom, rock and roll, Costco. River Dog Jenny on the gram. Have a wonderful day.